You've probably heard of the butterfly effect before. It's the idea that if a butterfly flaps its wings, it causes a tornado halfway across the world. You might also have seen the 2004 film of the same name starring Ashton Kutcher. In the film, Ashton Kutcher's character, Evan Treborn, has an ability that allows him to go back in time and make different choices in his life. Every time Evan travels to the past, he hopes to get better outcomes for the future events of his life. But when Evan makes new choices, he always seems to make things worse for either himself or someone else. Even the small choices he makes have astronomical consequences because everything is connected in some way. Now, the Butterfly Effect film paints an over-dramatic tale about what the butterfly effect is and what it can do. The real butterfly effect is much more scientific, and it's not just about the decisions that people make throughout the day, like many people believe. Edward Lorenz, a professor of mathematics and meteorology at MIT, was the one who proposed the concept of the butterfly effect in the late 1960s. However, despite its name, Lorenz wasn't really talking about actual butterflies having any effect on the weather and causing tornadoes. The name of the theory actually comes from Dr. Phil Merriless. Dr. Merriless suggested it as a good title for a talk Lorenz was giving on the theory and his research. The full title of Lorenz's talk was "Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?" The initial theory was about atmospheric predictability. Essentially, Lorenz stated that when it comes to weather, even small changes can affect it in a major way. Lorenz really discovered the butterfly effect by accident. One day he was using a computer to perform a weather prediction, and after getting the initial numbers about the prediction from the computer, he wanted the computer to repeat the process. However, when entering the prediction conditions, instead of typing in a decimal space followed by 6 numbers, Lorenz only typed in 3, shaving off the last 3 decimal points. He didn't think this would have much of an effect on the prediction, but surprisingly, just this tiny change of numbers produced results that were incredibly different to the original. What this proved was that any small change on a system can have a big effect, an idea that was quite new to science at that time. Lorenz later stated, one meteorologist remarked that if the theory were correct, one flap of a seagull's wings would be enough to alter the course of the weather forever. The controversy has not yet been settled, but the most recent evidence seems to favor the seagulls. This statement, along with the title of Lorenz's talk, helps lead to the common idea of the butterfly effect, meaning even the smallest of actions can have catastrophic consequences. This is the idea that most fiction based on the theory present to the audience. It is also why most people view the butterfly effect as something way more dramatic than it is, and even as something scary or dangerous. The butterfly effect isn't scary or dangerous, and it doesn't mean that consequences of small changes always have to be horrible. The butterfly effect also doesn't just apply to weather, it can be applied to anything at all. Any system can be affected in large ways by small changes, something known as sensitive dependency on initial conditions. These systems can be weather patterns, the solar system, or even the way social groups interact. Along with the butterfly effect, you may also have heard of something called chaos theory. This is the larger theory from which the butterfly effect originates from. Chaos theory poses the idea that there are some systems, such as Lorenz's computer simulation, that are very sensitive to any sort of changes, even if they are small. These are known as chaotic systems, and they can also seem as if they're completely random. However, these chaotic systems are actually governed by a set of rules, and once we understand those rules, we can more easily understand the system and make predictions about it. Chaos theory has changed the way scientists see the world. For a long time, most of the science world was governed by Newtonian physics. For example, that a small change in procedure would always equal only a small change in result. But when chaos theory came along, it became clear that all of the systems in the world aren't that simple. You could make a small change to something and it could have a major result. And there are also many changes that can have major effects on something. Also, things you didn't even consider as being able to affect something can actually be more linked together than you initially thought. At first, This seems daunting. If everything in the universe is just random and chaotic, then there's no point in studying it, right? Nobody would be able to understand anything if it's affected by the smallest thing and just keeps changing all of the time. Even though the universe is more chaotic than we once thought, it can still be understood. There are still clear rules and patterns that keep it organized. And scientists and mathematicians continue to study these every day to build their understanding of them. There is a good example from mathematician Ian Stewart to explain how chaotic systems work. To understand a chaotic system, you need to work out its attractor, which is the scientific name for its set of behaviors. The example by Stewart involves dropping a ping pong ball into the ocean. Because the ping pong ball is light, it will float to the surface if let go underwater. If it's dropped from above the water, the ping pong ball will drop to the surface due to gravity. The attractor in this situation is the ocean surface. No matter what, the ping pong ball will always end up there. It might get thrown around on the waves or carried a short distance in the air if the winds are strong enough. But despite this chaos, we know enough about the rules of the ping pong ball to know it will always end up on the ocean surface one way or another. The ping pong ball itself, where it is released, either under or above the water, the waves and the wind, are all different factors in a chaotic system, but they can be understood and measured, and therefore produce relatively predictable results each time. Phase space is what is used to describe the different behaviors of a system. It's not necessarily a physical space, more like an imaginary one. An easy way to think of it is like a road. A stable system with predictable behaviors is like driving a car from one place to another on a perfectly straight road. It's obvious what's going to happen, and there's no other way the car can get to where it's going. We can make a very confident prediction about this type of system. A complex system is like a winding road through the hills and valleys with lots of different turns. The car will still get to where it's eventually going to be, but the journey there will be less easy to predict. So, chaotic systems are not actually as hard to understand as we think. Once scientists and mathematicians can work out a chaotic system's rules, it can become easier to predict how the system will behave. Another great example is weather patterns. Meteorologists over time have learned more about how to predict them accurately, even though weather systems sometimes seem so random and unpredictable. However, weather patterns are actually called patterns for a reason, and typically tend to behave in the same way over and over again. For example, a high-pressure system usually means nice weather. Understanding the rules of these weather patterns means that meteorologists can make more accurate predictions about the weather. There are many other chaotic systems that can be better understood by discovering their rules. These are things like the universe, climate change, or even the human brain. Chaos theory proves that many things in the world, in the entire universe itself, are a lot more complex than we once thought. And so that leads us to the question, how much chaos can really be caused by the butterfly effect? Well, potentially a lot. As we've previously mentioned, even a small change on any system at any time could cause big problems. For example, changing the sequence of a set of traffic lights to change signals slower than before could cause traffic to back up, which could cause an ambulance to be unable to maneuver through traffic, which could cause someone to have an accident to not get help straight away when needed. However, you probably don't have to worry about a tornado resulting from a butterfly flapping its wings, or you ruining your life because you chose to wear sandals instead of sneakers to work one day. You'll probably just end up with sore feet. While it is true that everything in the world can have an effect on everything else, there's no point in spending your life agonizing over every decision you make, as long as you just try to do the right thing as much as possible. So, what are your thoughts about the complex topics that are the butterfly effect and chaos theory? Let us know down in the comments below. If you thought this video was interesting, please share it with your friends. Also, don't forget to subscribe to the channel for more interesting videos. We'll see you in the next video.